Alright guys, the second video here is LT2 and 3. We're going to cover two videos in this, or two learning targets, excuse me, in this video, just because they really go together. Learning target 2 is solve linear equations. Learning target 3 is justify each step in solving a linear equation. So they go hand in hand. So we're going to first go through the 5 steps of solving equations. You have space to write all of this on your notes. Make sure everything I write, you write. Okay? Everything I write, you write. Your notes should be full when I see them in class. All right? So step 1, we've already done this. This is the distributive property. Step 1 is if there's parentheses within the equation, we need to eliminate those parentheses by distributing. So here in this example, we're going to distribute the 3. Remember, distributing is 2 swoops of multiplication. 3 times x is 3x. 3 times 4 is 12. So this turns into 3x plus 12. All right? You can distribute negatives. If this were a negative 3, we would have negative 3 and negative 12. If this were a negative 4 or a minus 4, it would have been a negative 12. All right? So positives and negatives can be distributed. That's the start to that. Step number 2 is combine like terms. This used to be add like terms, but we decided to write it as combine like terms because you can add or subtract like terms. So we have 3x's and 2x's. Those are like terms. We know they have the same variable. Okay, if we had plus 6 over here, then the 4 and the 6 would be the same variable. But we just have the x's as our like terms. So that's 5x plus leftover is 4 here equals 20. Now if we had 20 plus 8, then we could add those two. Those are like terms. So you have to do that to both sides. So whichever side, I like to draw a line down from the equal sign, balancing out. Remember, if you treat this as a scale, 20 should weigh as much as 2x plus 4 plus 3x, or 20 should weigh as much as 5x plus 4. Golden rule of algebra, do unto one side as you do to the other. So we're going to get into that with step 3. We have to make sure the variable is on one side. I'm going to change this in my example to a 12x because it'll be easier in the long run here. So if we have the variable on both sides, and both sides, I mean both sides of the equal sign. I like to draw a line down there to know what I'm dealing with here, where my balancing point is. Then I need to make sure it's on one side, because if we're going to get x equals, if we're going to isolate that variable, we can only have one of them. So we either have to move 12x or 6x. We use the rule that you get rid of the smaller one. So I'm going to subtract 6x from both sides. And then 6x minus 6x equals 0. So those just cancel. We have 4 left, and then 12 minus 6x is a remainder of 6x. Okay? Now over here, if we had like negative 5x plus 3 equals 2x plus 7. Now what's smaller, negative 5x or 2x? Negative 5x. So to get rid of a negative, then, here's my line down, I would add 5x's to both sides. So then I'd have 3 equals 7x plus 7. All right? Bringing us to step number 4. Step number 4 is eliminate the constant term. Constant term is on the same side as the variable, okay? But it's by itself. It's not by the x, okay? It's not connected to the x. So to remove this 7, which is our constant, we would subtract 7 using the subtraction property of equality. So then I'm going to have 3x and 7 minus 7 is 0, so those cancel, equals 17, or 19 minus 7 is going to be 12. Okay? I could also have 3x or minus something, minus 2 equals 19. Okay? So then to get rid of that 2, I would add 2 to both sides. So I'd use the addition property of equality, and then I'd have 3x equals 21. All right? And then finally we have to get rid of that 3, which leads us to step number 5. Eliminate the coefficient, that 3, that number in front of the variable, either multiplied or subtracted, multiplied or divided, excuse me, with the variable. is called the coefficient. I remember it because I went to college. Coefficient. So to get rid of 3 times x, we're going to do the opposite. We're going to divide by 3. Now, what's 3 divided by 3? It's not 0. 3 divided by 3 is 1. So we have 1x left. And then what we do to one side, we have to do to the other. 12 divided by 3 is 4. You could also see this in this way. X divided by 5 equals, let's say, 4. Now, x divided by 5 is equal to 4. So to undo that division, we need to multiply by 5. And then 1/5, or dividing by 5 times 5, is again going to be 1. So we have 1x equals 20. You might also see that as 1/5. Dividing by 5 is the same as multiplying by 1/5. 1/5 x equals 4. That means we just have to multiply by the reciprocal. So multiply by 5 over 1. Those cancel. And multiply by 5 over 1. Again, we get x equals 20. So the coefficient is whatever's multiplied or divided right next to x. And those are your 5 steps for solving linear equations. The next thing we want to do is, this is learning target 3, we want to justify our steps. So using correct vocabulary basically here. You don't always have to justify, you're only going to have to justify when we ask you to. And that's basically going to be 1 learning target on the test. If you remember on the pre-test there was an area where you had to justify, and some people did and some people didn't, and some people tried their best. But I'm going to teach you the appropriate words to use when justifying. So if we solve this equation, if we're thinking about step 1, no parentheses, don't need to do it. Step 2 is add like terms or combine like terms. Over here I don't have anything the same. We have an x and a no x. Over here we have an x and a no x. And we can't combine like terms when they're on opposite sides. That's why I like to draw down this line so I know if I can combine them or not. What I do need to do is get the x to one side. I have to get rid of the smaller one. What's smaller, 5x or negative 6? Negative 6x. So I'm going to add 6x to both sides and then combine these like terms. So 5x and 6x equals 11x minus 6 equals 16 now because these two canceled. And then over here, so what I did there is I used the addition property of equality, and then I combined like terms. So that's my justification. Again, now I'm going to remove my constant by adding 6 to both sides. And then those cancel, and I'm going to combine these like terms to be 22. So I have 11x equals 22. What did I do there? Justifying, I used the addition property of equality and combined like terms again. Finally, to get rid of the 11, I'm going to divide by 11. And that's using the division property of equality. And we have 11 divided by 11 is 1x equals 22 divided by 11 is 2. So that would be how you justify each step. Using which property, what did you do, is basically what you have to tell us. So let's try another one. This time we're going to use the first step. I'm going to distribute this 8, but notice this is a negative 8 or a minus 8. So I like to make sure I know that that's a negative 8, so I'm going to do plus a negative. So negative 8 times 6 and negative 8 times 1 is what we're going to do here. So we're going to have 4x. Negative 8 times x is going to be minus 8x minus 8, not minus 1, minus 8, because 8 times 1 is 8, equals 8. Okay? So what did I do there? I used the distributive property. Okay? Then I'm going to combine these like terms. I have two x's on the same side, so I can put them together. 4x minus 8x is going to be a negative 4x. Minus 8 equals 8. What did I do there? I combined like terms. Then I'm going to add 8 because I'm going to remove my coefficient. So I'm using the subtraction property of equality. Actually, and these are kind of interchangeable. I did add, so it could be the addition property of equality, whatever you want to call it. And then I need to combine these like terms. So this cancels. This is 16. So I have negative 4x equals 16. Finally, I'm going to divide by negative 4. Divide by negative 4. That's using the division property of equality. And x equals negative 4. Okay? So that's the justification. Be sure if you have any questions on the justification, fill out that question form below the video so that I know, okay, they're not fully understanding this process. Special cases. Now, we're not going to justify these steps, but I do want to go over a couple cases where it just comes out weird because one of them happened on the pretest. So, and some of you understood it, some of you didn't, some of you just knew there was something wrong with it but couldn't really figure out what. So let's look at these special cases. Just by doing our normal steps, we'll kind of figure out what's weird here. So I'm going to start with distributing. Distribute my 2, so I have 2 times x is 2x plus 2 times 4 is 8. And then minus 5 equals 2x plus 3. Always a good practice, best practice to just write out each step as you go. So then I'm going to add like terms. So I'm going to have 2x plus 3 equals 2x plus 3. Now, notice when I'm just saying that 2x plus 3 equals 2x plus 3, that equals the same thing. That seems right? So what's going to happen here is when I get the variable to one side, if I minus 2x from each other, or from both of these, I'm going to get 3 equals 3. Or if I go a little backwards and I minus 3 from both sides, I'm going to get those cancel, 2x equals 2x. Well, duh, 2x equals 2x. But what this means is that x just equals x, because if I divide both of these by 2, then x just equals x, which means you can put any number in here. You can put 5, 6, a billion in this equation, and this side is going to equal this side with any number. It doesn't just have to be one number. In these cases, it was only -4 that made this true. It's any number will make this true. So what we call that is infinite solutions. Infinite solutions. Any number, all the numbers, any number you can think of. Say a number, it works, okay? So that's one of the weird ones. That's my favorite type of weird one because everything works. Here's our least favorite, most of all. Mostly. I don't know, maybe it's your favorite. But if we do this, so let's start with combining like terms since we don't have parentheses. 4m minus an m is going to be, and everybody knows that if there's no coefficient out in front, that's just 1, right? That's going to be 3m plus 1 equals 3m plus 9. Now here you're going to notice it's kind of like this, but it's not. If we subtract 1 here and we subtract 1 here, then we have 3m equals 3m plus 8. Now, if I have 3 times something, it's not going to equal 3 times something plus 8, right? And if I take this further and I get my variable to one side, so let's say I want to get rid of this 3m, but then I have to get rid of 3m on this side using the golden rule, then that's 0. And that's 0, so all we're left with over here is 8. And then we have 0 equals 8, which it doesn't. So what does that mean? Well, there's no number, there's no m where you can plug it in and have 3m's equal 3m's plus 8. This one's always going to be 8 more, right? This one's always going to be bigger than this one because you're taking it times the same thing, but then this side you're adding 8 to it. So what we call this is no solution, or unsolvable, okay? There's no number, nothing in the whole world, in the whole universe that can be put in for m to make these two expressions equal, all right? Nothing. So moving on, your before class work, and this has to be done. Some people aren't doing their before class work, and that makes me angry. Is to write an equation to have your partner solve. So when you come into class, we're going to have you and your partner work together, and you're going to give this problem to your partner, and they're going to solve it. But you need to make sure that it's solvable, that it turns out nice, that it's a pretty problem. So you need to solve your problem so that you can end up checking their work in class. And the point of this is that I want you to realize that it's not easy to make these problems come out nice. I mean, all problems, most problems, can be solved, but not all can be solved so that it looks pretty. Okay, some get nasty, some get dirty. Like when I'm doing this one, when I take no, that one works too. Here, this one's going to be a decimal, right? Because if you end up dividing by 6, you're not going to have a whole number. So make sure that your problem that you do for class has a whole number answer. It's a pretty problem for your partner to solve. All right, see you in a class.